Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of pgMustard, and this is my co-host Nikolay, founder of Postgres.ai. Hey Nikolay, what are we talking about today?
Hi Michael, let's talk about one more controversial topic. Can we run analytical queries in Postgres and what to expect from it?
Yeah, right. So like real-time analytics workloads, maybe in combination with transactional workloads. Sometimes people say hybrid, but I think it's a fascinating topic, and luckily another listener request, so thank you. And sorry it's taken us a while to get to this one, but really appreciate it. So yeah,
hybrid is just a term OLTP guys invented to pull to everything to their side. I mean, it's still OLTP, but let's run aggregate queries in a regular OLTP database and try to achieve better performance, right? Let's try to get rid of analytical databases like Vertica or Snowflake and so on. This is HTAP. Because it's not vice versa. It works less often, right? Like analytical for OLTP, it usually doesn't work because latencies they have are awful.
We're diving straight into the deep part of the conversation, but I have seen some go after trying to do both, like single store and like a few. I was going to bring this up later on, but I do see some analytical providers like ClickHouse starting to add features that allow them to do some of the to mitigate some of the trade-offs or the bad.
Do they have already updates and deletes?
I haven't checked, but I think
do they work okay? Do they have already good isolation for sessions? I mean, isolation control.
But this is
snapshot isolation and so on.
Let's rewind. Let's go back.
Like, what do we? Like analytical data systems were not designed to be ACID compatible. They don't need it. They need to sacrifice some aspects for the sake of processing huge data volumes, right? So I doubt. Like, for example, Vertica, if it would be so easy, I cannot imagine someone runs Vertica to handle some, like, I don't know, like social media or e-commerce kinds of workloads. I mean, user-facing workloads. When customers expect all pages to work below 100 milliseconds, right? Better 1 millisecond. On average, it should be below 1 millisecond on server side. And I cannot expect that someone can run Vertica for that or Snowflake. It's like strange. So that's why I say HTAP, it's OLTP with attempt to improve performance of analytical queries. You don't agree, obviously, right?
Well, I think this is a really interesting time, and maybe that's true at the moment, but I think there's an interesting almost race between OLTP systems adding the ability to do more analytical work, and the more analytical side of things trying to do more transactional processing. And there's at the moment, most people either have two separate systems, so like extracting the data from the transactional side and putting it into the analytical side, or they try and get by as long as possible with the transactional side and optimizing for maybe a smaller amount of analytical workload. But I wanted to start by thinking, like, if you think of real-time analytics, like what do you think that includes, or what's the first thing that makes you think?
My bachelor thesis in university was about ETL and how to make clean up data to get rid of dirt, to make it to have like a unified schema for all data from various sources. And then my first job was in a company called Program Bank. We programmed software systems for banks using Delphi and Oracle. It was an interesting time. It was like more than 20 years ago already. And I learned that banks, obviously, they have process of data load during nights and a lot of processes during weekends. And then later, when I started to fly a lot in various like Europe to US and back and forth, and I've noticed that since I have bank accounts on both continents, I noticed that even I'm still noticing it. 20 years later, some banks still have nightly operations, so you cannot access your bank account during your daytime in Europe when it's night in the US and so on. So when I hear real-time analytics, I imagine that this should go away, this approach. And systems should be accessible always. And even if you need to provide some reports, like monthly reports or something, it should be done asynchronously at least, or better, in the same system. Like, okay, we have OLTP system, and we know how to handle analytical queries which process like month of data, right? So this is what real-time analytics to me. Not like banks do. Some banks. So there are new banks which already don't have this approach, and they follow good practices.
Yeah, well, I mean, some of those sound like they're not even showing you the transactional data, never mind the kind of aggregated data. But for me, this makes me think of, let's say you're looking at a software as a service dashboard, and you want to look at your total of some number or some average of some number, but it includes up to today and up to this minute of information. So you might be looking at page views on a website, but it includes the last hour or the last few minutes. And if somebody visits your website now, they start showing up in that dashboard as well. There's not really a delay.
There's no delay, and it doesn't go down, view count, unless some bots are involved. And also, if you open two tabs of the same page, you have at least similar numbers, right? You know the joke, how many, MongoDB reached 1 million downloads, or according to one of our nodes, 999 downloads, and according to the other one, 1,000,002 downloads. Right, you know this, right?
I hadn't heard that joke before, no.
An eventual consistency joke. So yes, I agree, and this is historically a very difficult task for raw store as Postgres, and with MVCC implementation Postgres has with all that tuple or tuple, I forgot, processing using vacuum process and bloat issues and indexes, index amplification, and so on. So historically, Postgres is known for very slow select count star or select count one, doesn't matter in this case. But it was improved. Some aggregate queries can benefit from index-only scans.
Yeah.
Some can benefit from loose index scans, but unfortunately, Postgres doesn't have it. It doesn't have automatic loose index scan. You need to program it using recursive CTE, so you need to tell Postgres how to skip certain subtrees in B tree. But many aggregate queries can be improved, so it's possible to achieve with Postgres. Right.
Yeah, you bring up a good point about, all the design decisions that make Postgres so good at concurrently doing inserts, updates, deletes. The design decisions that make that really efficient make running queries on, let's say, one column across all customers, if you're trying to sum those or average those or do some aggregation, it is fundamentally difficult, whereas a lot of these analytical systems are designed for the exact opposite. And as such, we've got almost a hard trade-off here, right? Like, I don't see, there's not an obvious way of having the best of both worlds.
It's possible with storage engines, and there's ongoing work for many years already, and it looks like sometime soon we will have some. There are projects. I always mix it, ZStore, Heap, I don't remember. Attempts to have pluggable storage engine which will provide column store. There was also a project from Shoutouts, it was called C-Store, maybe like column store, but it was using FDW, so it's not like native storage. Like it's not like in MySQL when you say this table needs to use this storage engine and that's it. But in general, strategic decision in Postgres project was made to have multiple storage engines, like to have API for that and so on. So in future we can expect that it will be easy to define some table as column storage based. Let's talk about differences. You raised a good question about when one works better than the other. If we have OLTP, we usually need to extract user data with all columns of that user, including like email, last name, and so on and so on. And of course, if these columns are stored ideally in the same data page, Postgres has usually like 8 kilobyte data pages. It's just one buffer read or hit. Speaking of buffers, right? Our favorite topic. But if like column store, like ClickHouse, they store each column of table in separate file. In this case, you need to deal with many files and then extract this data and then aggregate it in memory to provide a row. But if and this is how OLTP queries dealing with single row, or if you have pagination like 25 rows ordered by some column, it becomes less efficient to extract the data. But for queries like let's calculate sum of some orders or some aggregates for month, you deal just with single file. And if it's stored historically, and you need just 1 month, you deal with fewer pages. It's all about I/O as usual, right? And the amount of memory you need to allocate and work with.
Yep. And while we're talking about kind of systems that allow for you to pick your trade-off maybe on a per table basis, we've also, I think, probably should mention that there are extensions attempting to do this kind of thing as well, and the most obvious one being timescale of doing doing some level of, it's not exactly column store, I don't think, but I think it works the same way. But it's very clever. But the other thing that they take advantage of, and a lot of the other analytical systems.
You mean compression in timescale for time series, which understands which uses the knowledge about what stores in column and applies this to compress, right?
Yeah, but that's exactly what I was going to say. Because data within a column is very likely to be similar across rows. Yeah. It compresses extremely well. And another thing that can reduce I/O for those analytical queries is that there's just less.
I encourage everyone to read their articles, especially one explaining details about compression approaches for time series and timescale. I read it from time to time and keep recommending it. It's a brilliant article. And in general, work is brilliant for these types of data. But wanted to mention also Hydra, which is a very new project, which is aiming to build analytical type of Postgres, like Postgres flavor. And they also work in this area. They took Citus, this store for column store, like via FDW and Improve and so on. And we had an episode on Postgres TV interview with founders. It's it was one month ago or so, but it's still getting a lot of good feedback. They shared feedback. They get personal feedback. That's great. I mean, it's interesting project, and I encourage also checking out this interview. So yeah, like by default, I think all people should start from Postgres, right? And then we don't want to be like banks, right? We don't want to have ETL every night. It doesn't scale well, this process. I mean, at some point it will like take more and more hours, and you don't have so much time, and like it's hard to manage this process. And also customers suffer because if they want up-to-date info, no, you need to wait until tomorrow to get this info. No, it's not good. And customers can be internal in this case because, for example, business owner might want to see some reports right now, but we would tell return tomorrow. No. No. So we start with Postgres, and then we have two options basically. First is to take something for analytical, and this is our default option still. OLTP Postgres DBAs usually recommend, and I usually do the same, don't use Postgres for analytics. This is mantra actually. We use this mantra all the time because the problem is not only it's less efficient for heavy queries with aggregates, it also affects your health of your Postgres. Because if you run it on the primary node, if you have very long query lasting half an hour, for example, and during that time other queries deleted in any table, they deleted dead tuples, AutoVacuum cannot delete these tuples until your long query finishes because you hold X-min horizon. Right?
So yeah, we've talked about this a few times, and I think this might be the one time I disagree with you because we're talking about real-time analytics here. I think if we're talking about things that update that are user-facing, people are going to have problems way before half an hour in terms of user experience. So I think we're talking, I think more in the region of the customers I see doing this kind of optimization work within Postgres. It tends to be they're trying to get something to load within, ideally, a few hundred milliseconds or 5 seconds kind of, 10 seconds kind of upper limit of how long somebody will wait for maybe if they're changing some drop downs in a UI and then they want to refresh their data. If we're talking about that being able to finish within a few seconds, I think that can still live within Postgres for a while. Maybe it doesn't scale forever, but it's smaller at smaller sizes. I definitely don't.
You are right, but only until some point. If so you basically say real-time analytics means that we have a requirement to have statement timeout 15 seconds, for example, for all user-facing queries. That's great. I agree. But to achieve that, you probably will face challenges when you have select count or select sum or anything lasting too long. And then you will implement some denormalization asynchronous via some queuing mechanism through Kafka or something to pre-process some data, for example, on hourly basis. And those queries you won't limit, right? And those queries will hold your X-min horizon, like backend. How to say them? Like how to name them? Backend queries or something, not user facing. Some batch processing queries, something like that. And to keep everything in Postgres, right? You need to have some pre-processing, asynchronous, in parallel, queued, and so on.
And we've talked about, we should probably give a shout out to a previous episode we did on materialized views, which are one kind of pre-processing tool. Probably going to give them a couple more shout outs in this episode. So I was gonna say Timescale actually with their continuous aggregates.
Is great. Timescale is great. Again.
Well, the continuous aggregates are kind of this pre-processing, right? Where you have this continuous aggregation of new data coming in, and then that getting filed away. So I think there are some ways of avoiding what you're talking about, but only up to a point.
Continuous aggregates and timescale, and this is a part of their open source offering. So that's great, and I know cases where it works very good. I also need to. I made a joke today about someone from Timescale offered me to register in Timescale Cloud. First of all, of course, I'm registered there, and I need to say that I said no, don't go there because there is no bottom in Timescale Cloud. It was a joke because about their bottomless feature. We probably also discussed it. Of course, go and register on Timescale Cloud. It's great. A lot of new, very new approaches, very interesting approaches, and I think Timescale is one of the companies which drive Postgres ecosystem forward using innovation. That's great. So right. So if we want to keep everything in Postgres, we will have these type of challenges, long running queries. Sometimes we can avoid them if we choose smaller batches. If we process this, if we implement this asynchronous process more often, every minute, for example. But it also worth mentioning, it's hard to engineer it because Postgres doesn't have what Oracle provides, autonomous pragma autonomous, something like I want to detach my auxiliary transaction for background processing. For example,
cool.
We inserted some data and we want to increment some count. We would like to do it asynchronously, not blocking the main insert, right, or main update. And to do that, you need to engineer it using some Kafka or some, I don't know, like RabbitMQ. Cannot recommend RabbitMQ or Sidekick or something, some queuing. By the way, there is a new project someone released a couple of days ago, which is considered as a replacement for pgQ, but it's another story. Q in Postgres, we need to discuss it one day. So but if you manage to engineer it, probably you can keep your transactions below some duration. But if you don't, you have a trouble, and you cannot. You cannot even offload some long-running selects to standby nodes, because either you need to be a single user on that standby nodes, because other users will notice long legs, big legs when your query lasts, or you need to turn on hosted by feedback, report to the primary, and have all the issues with bloat again. So what to do? Back to my idea that we have two options. One option is find a way to remain in Postgres using some optimization, some column store approaches, some innovation, or to use some regular approach, but with continuous ATL basically, which is called CDC, change data capture. So you take something. You can take, for example, Snowflake and not Snowflake, ClickHouse, and use it as a secondary database right from your application. It's kind of there might be problems with consistency, because probably Postgres knows that you made 1,000 sales today, but ClickHouse thinks it's slightly less or more. Usually, Postgres is considered as a primary source of truth, being OLTP system. And then we have a logical replication to Snowflake, Vertica, or ClickHouse, or anything else. There are ways to do it, but you need to deal with logical replication. This is challenging. It's possible, but it's challenging. I must admit it's improving. Every year, Postgres receives improvements in this area. And there are tools, including commercial tools. Open source is Debezium, but there are commercial tools. I cannot recommend Click. Their implementation. Click is bad. Former Attunity, I think, right? It's just wrong implementation of Postgres plugin. But for example, Fivetran is quite good if you consider commercial systems.
And we have a whole episode on this, right? We have
it's
on replication.
Different story. And so our option as real-time analytics is to improve queries. Let's talk about the ways to improve.
Well, and so another thing I was going to mention that I think is important here is generally once we have performance issues, or once we have a decent amount of data, we're doing analytics, we probably are in the realm of needing or wanting to use partitioning of some description.
Oh, partitioning is huge. Partitioning is a must-have if you need to deal with big data volumes. Like rule of thumb is you need partitioning if you have for a table which exceeds, for example, 100 gigabytes. Right, you definitely
which is a lot, but also not that much these days, right? It's
right. And partitioning is needed in many aspects, including data locality. So all data lives in particular pages, data blocks on disk, and they are all frozen, very rarely touched. So to vacuum just skips them very quickly.
Yeah.
And also indexes for those old partitions are in like almost frozen shape, quite efficient, maybe rebuilt, not degrading. And these pages don't are barely present in our buffer pool and operational system cache. Because if everything is mixed and each page has a couple of new tuples and a lot of old tuples, it bloats your shared buffer. This is one of the biggest reasons of partitioning, to have partitioning.
Another reason that I think is
also I just recently revisited this topic several times with a couple of customers, and also like in Postgres 14, I think, in 14 Postgres 14, reindex concurrently and index concurrently. They got optimization not to hold X-min horizon. It was so great. So you reindex, and even if you have a terabyte or 5 terabyte size table, you can perform index maintenance, because we all need rebuild indexes from time to time, even if it's not Postgres. In all TP systems, they degrade, and their health degrades. So you don't hold X-min horizon, so it doesn't matter if it takes hours, right? But it had a bug, and in 14.4 it was reverted. So it means if you have huge table, you need to rebuild index holding X-min horizon. It's the same problem as we just discussed with inability of AutoVacuum to delete tuples which became dead recently, right? So that's why you need to have partitioning, and everything improves, including index behavior and so on. Sorry
I think
for
there's
long speech.
Yeah, well, I think there's another good reason, and I think it encourages good practice around maintenance and around retention. I think a lot of people, before they have partitioning, don't even consider deleting old data or how long they should be holding certain data for, and a lot of the time it is partitioned on time, or at least one aspect of it as time. So I think it does encourage you to think about how many of these do we need to keep around, and how easily can we get rid of them, that kind of thing. But maybe not so at analytics.
Here again, the time scale pops up. Like they do very good job to achieve HTTP for Postgres for time series, because again, this bottomless I mentioned, this is exactly how they implemented it, and I like it. So for partitions with archive data, you can choose S3 as storage, right?
Yeah, smart.
And for hot partitions, it's on EBS volume in AWS, for example, if it's AWS. And for your application, everything is kind of transparent, so you don't notice it. Of course, archive data is slower, but and everything is, you can see it even in explain and analyze that S3 was involved.
Really, that's cool.
Yeah,
I haven't seen that.
It's a fresh feature, I think, bottomless. But this works only in cloud, unfortunately, as I understand.
Okay, makes sense. That's a good point, that they automate the partitioning for you, or once you choose certain things. But the normal way of doing this, the place that's the extension that seems to be most popular is pgPartman, right? For automating.
I must confess, I never used it myself.
Yeah,
a lot of folks around did it, but I didn't. But I implemented partitioning myself before partitioning became declarative. So I have some experience with partitioning and with declarative partitioning as well. But with partitioning, the general advice, you need to choose as fresh major version of Postgres as possible, because again, a lot of progress was made during the last 5 to 7 years. Ability to detach partition concurrently and so on. In non-blocking way. But I wanted also to mention that the same thing as Timescale did, you probably can do yourself using FDW if you convert your old partitions to foreign tables. Using Postgres FDW, for example, you can store them on remote server with slower disk and so on.
Yeah.
Cheaper.
You just reminded me actually of it's a different slant on that. But did you read the post by DuckDB? They're an analytics database, and they've done some incredible work. I didn't fully understand it, but they you can now query Postgres. Like you can have your data in Postgres, but query it through DuckDB, like kind of like an FDW, but in reverse, and get some ridiculous performance improvements on the same queries.
But when we use FDW, I'm afraid we will break our requirement. We won't meet our requirement to be below 15 seconds at some point at some data volumes. I'm afraid. My gut tells me, but maybe I'm wrong. I actually don't follow all new stuff happening in Postgres ecosystem. It was so like at least 5 years ago, definitely 10 or 15 years ago. Right now, I'm feeling I cannot catch up with everything. It's too many things are happening.
I highly recommend this post by DuckDB. I'll link to it as well. But some people I really respect are singing their praises at the moment. So I'm looking forward to understanding that one a bit better. And the other one I wanted to make sure we mentioned, I don't feel like we should talk about Postgres and real-time analytics without mentioning Heap. They do quite a lot of blog posts related to Postgres. And I think, I could be wrong, I could be a bit out of date here, I think they're running Heap, which is an analytics product, pretty much exclusively, I think, on Postgres. Maybe with Citus, I think.
I didn't see fresh articles from them, but I think it was 4 or 5 years ago when I learned, and I remember they used ZFS with Arc2, with data stored on EBS volumes and with local disks and local NV. Like it was time when Nitro in AWS was not released, I think, and EBS volumes were much slower than local NVMe disks, which are ephemeral. So if machine reboots, probably you lose data there. So what they did, as I remember, of course, partitioning was involved, I'm quite sure. A lot of nodes, and I think also sharding was involved. Right. But they store data on EBS volumes, quite cheaper, and Arc2 cache in ZFS was on local NVMe's, so it's like interesting system. But I never tried to implement it myself, this approach with ZFS.
Yeah.
Despite of the fact that in my product database lab engine we use ZFS, but we use only regular Arc in memory, like alternative to operational system cache. Never played with Arc2, so I cannot tell that this works well. Maybe, but it's an interesting idea.
Yeah. Is there? I suspect we could talk about this for quite a while. But is there anything else you wanted to make sure we cover?
Well, there's also materialized views are a very important topic, and this is also not fully solved. So, I think engineers should know what Postgres can do, right, and provide out of the box, and what Postgres cannot do in this area of real-time analytics. You should be ready for degradation, and you should experiment with larger volumes. Definitely, you should tune auto vacuum to be quite aggressive to keep visibility maps up to date. And this is must-have thing. So your benefit from index-only scans. For example, you loaded data, you vacuumed once, visibility map is fresh, and your select count or select some select with some aggregate works quite fast because it doesn't consult to heap pages, because heap fetches is 0 because visibility maps are very fresh. But then a lot of deletes are coming and it degrades. And if auto vacuum is not aggressive enough, by default it's not at all. You will see heap fetches in plans growing and performance degrading. So you need to tune auto vacuum. But 3 things Postgres doesn't have. One, I mentioned this, like asynchronously detached sessions with transactions which will process, help us denormalize data, right? Second, partitioning is not fully automated in terms nobody will create partitions for you automatically, right?
Yeah.
Or
very important.
Old one. You need to engineer additional pieces here. Of course, that's where timescale shines again, because it does this.
Or use pgPutman.
Right.
Or similar.
So, right. And third thing is that, again, materialized view can be refreshed only as a whole. It can be done concurrently, so ongoing queries are working, but it can be refreshed as a whole. And it also can get bloat and so on and so on. There is no incrementally refreshed materialized views. This idea is one of the biggest ideas Postgres project has, and there are projects around it. There is a wiki page that discusses how to implement yourself. It's possible, but some engineering effort is needed, definitely. But if you manage to have incrementally updated materialized views and asynchronous workers which denormalize your data, and also implement automatic partitioning, you can achieve real-time analytics in Postgres at scale few terabytes or dozens of terabytes at least. Also, I wanted to mention one extension. I think it was developed at Citus back in the days before Microsoft as well, called hyperlocalog. It helps with count distinct, right? Hyperlocalog, right?
It's like one of the options for providing a good estimate for it, right?
Yes. Also, I never used it myself in my projects, but I recommended some folks used it. It doesn't solve all problems, but in some cases it's useful.
Right. Yeah, there's an excellent post on the Citus blog that we actually linked to within pgMustard for when we spot slow counts. They did a really good post listing a bunch of ways that you can speed up counts, whether you need an exact number or when an estimate can be good enough.
Yeah, I remember a good old trick with estimates. If your auto vacuum is tuned aggressively, so it has an analyze part to maintain raw statistics, and if implement some function. If you provide some query, instead of returning data, it returns raw estimate from it, extracts it, and say, okay, raw estimate roughly is this. But you need to be friends with your statistics and auto vacuum to rely on this information. Sometimes it's very off, depending on filters and so on. But okay, I think despite a lot of name dropping we did, right? We provided some principles as well, what to expect, and I think definitely it's achievable at the scale of terabytes or dozens of terabytes, and even thousands or maybe dozens of thousands of transactions. It's possible to handle, but it's still not as good as performance of column store for aggregates, and unless you use one of the projects we mentioned.
Yeah, exactly. There is a limit, and if you're building an analytics product where people need analytics as their main thing, there's a good chance that you won't want to use Postgres for that data, right?
Right.
But yeah. Awesome. Thank you so much, Nikolay. Thanks, everybody. Thanks for the suggestion as well. Keep those coming, and see you next week.
We have enough, actually.
Oh, we have a lot, but let's maybe add plus ones.
Let's pause a little bit. We need to process what we have so far. I'm joking.
Well, take care. Have a good one.
Bye-bye. Thank you.